15 kilometers per hour.
15 kilometers per hour. So I could say that dx dt equals 15 kilometers per hour, and there's going to be a problem with this. The problem is that when we deal with rates, the sign matters. You guys just told me that x is getting smaller, right? X is decreasing. The way that I indicate decrease in a calculus class is negative. So dx dt is going to be negative 15 kilometers per hour. And do the units make sense? Well, let's take a look at the units. The units are kilometers per hour. I'm measuring how x changes. X is distance, kilometers. T is measured time, hours. Do the units make sense? Good. So let's keep going. Edgar, what else is happening here?
The other ship is moving at 10 kilometers per hour.
The other ship is moving at a rate of 10 kilometers per hour. How am I going to write that? We've got 10 kilometers per hour, but how am I going to write that? Ship B is moving away, right? They're using y to indicate the distance from the lighthouse rock to the ship.
Oh, dy over dt.
So this has to be dy over dt. Anthony, what do you think? Positive or negative here?
Positive.
Positive way. Because the ship is moving away, so it has to be a positive distance. So ship A is always getting closer to the lighthouse. Ship B is always getting further away from the lighthouse. We're good. Folks in the back, we're okay? All right, so what else do we know? We know, did it tell us anything else? No, I think that's it, right? So let's look at part A. Part A, find the distance in kilometers between ship A and ship B when x equals 4. So if x is equal to 4 and y is equal to 3, how am I going to find the distance? How am I going to find the distance? Jasmine, what are you going to do? You're going to do the Pythagorean Theorem. Right? Not even a calculus question right now. It is just a question of what is this distance here, which I'll call z. If I use the Pythagorean Theorem, I can say, oh, that means that 3 squared plus 4 squared is equal to z squared. What is that, 25? So z is going to be equal to 5. And the units?
Kilometers.
Has to be kilometers, not kilometers per hour, because we're not talking about a rate. And you might think, okay, like that's great. That had nothing to do with calculus. You could do that in a geometry class. Absolutely. Folks in the back, is everybody okay? It's not that you guys aren't important, but I want to focus on these guys right now. All right, part B is finally when we actually get to a calculus question. Part B, at what rate is the distance between the two ships changing? I want to know the rate at which the distance is changing at the moment when x equals 4 and y equals 3. So there's another rate coming into play here. And that rate is the rate that the distance between the ships changes. Now, if ship A was heading, what is that, east? And ship B was heading north, what would be happening with the distances? If ship A is heading east and ship B is heading north, then the distance would only increase, so that rate would have to be positive. If ship B is heading towards the lighthouse going south and ship A is heading west towards the lighthouse, that distance would have to be the distance is shortening, so it's a decrease. But I've got one guy going north, so going further away, one guy coming closer. It's possible that that distance between them is increasing. It's also possible that it's decreasing. I don't know. But what I need to do the calculus is I need an equation. I need something that is going to connect all of these guys all the time. I need something that's always true. And that something that's always true is your Pythagorean Theorem. Right? No matter how ship A moves, as long as it's heading, what was this, west? As long as ship B does nothing but go north, no matter where they are, don't we still have a right triangle? Okay? And because you've got, you're always going to have a right triangle, then you always get to use the Pythagorean Theorem. And this is what we're going to take the derivative of. This is the new piece. For folks that were here yesterday, I want you guys to hold back, because you guys are going. I want to take the derivative with respect to t. T is the important variable here. So the way I take the derivative of x squared with respect to t is going to be 2x. No big deal. We've seen this before. but I'm going to multiply by how x is changing with respect to time, plus I'm going to take the derivative of y squared, which is 2y, times how y is changing with respect to time. And that's going to be equal to the derivative of z squared, which is 2z times the rate that z is changing with respect to time. Whether you're the front or in the back, what are the questions that are out there? Everybody's okay? Okay. Well, what is it that I'm looking for? I want the rate that the distance between the two ships is changing. What I want is this guy here. My derivative equation connects x, dx dt, y, dy dt, z, and dz dt. If this is what I don't know, then I hope I know all the other things. And I think we know most of these things, right? So let's see, what's x?
Isn't that different? No.
At this particular time, x is 4. So we've got 2 times 4. dx dt.
Is it 15? No, that's 10.
This is where I want you to be careful. dx dt. Look at your diagram.
Negative 15.
It has to be negative 15. Plus 2 times the y is 3 times dy dt. What is that going to be? 10?
Yes.
Equals 2 times, now I need z.
5.
They were kind in this problem because in part A they actually asked you to figure out what that distance was. But if they hadn't, the expectation is you'd say, well, I know that x is equal to 4. I know that y is equal to 3. I know I always have the Pythagorean Theorem that I get to use. And so maybe you'd like do it off on the side with a little bit of side work. So 2 times 5 times dz dt. And just finish it off. 2 times 4 is 8. I think that's what, negative 120. 2 times 3, I got 60. Equals 10 dz dt. So dz dt is that negative 6? Folks that are in the back, did you guys get negative 6?
Yes.
Okay, I'm worried about, okay, we got other folks as well. Folks up front are okay with the negative 6. Have a conversation with somebody near you. What does that mean? How do you interpret this answer?
The distance is decreasing
At a rate
at a rate of
of -6 kilometers per hour. That's 6 and
So what I've heard from a lot of different tables is the distance is decreasing at a rate. Edgar, what are the Abraham? What are the units going to be?
Kilometers per hour.
Okay, does that make sense? Look at the tag dz dt. Would I measure that change in kilometers per hour? Z I'm measuring in kilometers, it's a distance. T I'm measuring in its time, it's going to be hours. Now your write-up has to look something like this. When is this true? What's happening? What moment in time is this true? Adriana, when's this true?
When x is equal to 4 and y is equal to 3.
When x equals 4 kilometers and y equals 3 kilometers. Great, we've established when it's true. What's happening? The distance between the two ships, what's that doing? Is decreasing at a rate of 6 kilometers per hour. Done. That was part A and part B. In total, I think that's like 5 points out of 9 on an AP exam. Folks that are in the back, keep going to the multiple choice. I want to take any and all questions from the folks that are in the front. So keep going to the multiple choice. Friends up front, anything that's not 100% clear right now? Yeah.
So the only equation that we're working with is
In this problem, right now, the only thing we're working with is the Pythagorean Theorem. Why are we using the Pythagorean Theorem? That's the important question. Because what? Because no matter how these ships move, you're always going to make a right triangle between the lighthouse, between the ship, and the ship over here. And so just like with optimization, there was like a constraint equation, right? That constraint always connected to your variables. That's what the Pythagorean theorem does here in this problem. Some of the problems you're going to do tonight for homework are not going to involve the Pythagorean theorem. Other questions from folks up front? We're good? All right, folks in the back, why don't you guys join the conversation now? Part C, let theta be the angle in the figure. Find the rate of change of theta in radians per hour when x is equal to 4 and y is equal to 3. In part C, I want to have a conversation with you guys about how theta is changing. If theta is changing, the notation for that? d theta dt. That's a really sloppy d that got away from me. D theta dt. What you need in order to move forward with this is an equation that involves theta. There are lots of options here. I'm going to pass out some papers, take attendance. I want you guys to have some conversation. What's the equation that you're going to use?
Bless you. Thank you. You're welcome.
Jennifer, hold it. Back there, Gonzalez. Adriana. Kimberly. Daisy. Daisy moved over here. Christian. Abraham. Edgar. Jasmine. David. Martyr. Anthony. There's all the stuff. Jennifer. All the stuff. Nora. This stuff. Mariah. There you go. Rombier. Jennifer. Giselle. Marvin. All right. So who's got an equation for me? Lots of options here. It is possible that we're not going to come up with the same one in all the groups. I need any equation that you know that involves theta. David. Okay, so you said sine. Now I need a full equation. Sine of what?
Oh, sine of theta?
Sine of theta is equal to what?
It's equal to...
How do we get sine? How do we get sine? Opposite over hypotenuse. So sine of theta equals y over z. That is that an equation that gets theta in there?
Yes.
Excellent. Other ones, other options.
Cosine of theta.
You could say cosine of theta. Cosine of theta, we would set that up as adjacent over hypotenuse. Great. Any other ones?
Tangent.
You could use tangent. Tangent of theta is going to be opposite over adjacent. So what is that? Y over x? As long as these relationships are true all of the time, you can take the derivative of this one, or you can take the derivative of this one, or you can take the derivative of this one. It doesn't matter. So pick one that you like. I mean, we're probably going to stay over here on this side of the swimming pool and probably avoid the tangent. But if you want to go with tangent, because maybe you remember that the derivative of tangent is...
Sine over cosine.
No.
Sine over sine.
Tangent is sine over cosine, but that's not the derivative. Derivative of tangent is secant squared. Since some of you have been away so long you didn't remember where the room is, not expecting a lot of folks to remember that derivative of tangent is secant squared. So let's take a derivative. Okay. Derivative of sine of theta with respect to t.
Cosine.
Careful, derivative of sine theta is cosine theta, not done. D theta. D theta dt, because we are measuring how that angle changes with respect to time. Derivative on the right, quotient rule. Right? I need the quotient rule. So Noemi, what's the quotient rule going to tell us over here?
dy over dt.
Oh wait, hold on. Let's do the quotient rule. So quotient rule starts with low. So low, and then
Minus
low, d high. Derivative of the y
1.
is dy dt. Minus high, d low. All over
Low, low.
low, low. What I want is d theta dt. I am confident that if you could successfully find that derivative, that is going to be worth 2 points right there. The question though is, do we know, can we find d theta dt? Well, if I'm going to get d theta dt, that must mean you know all the other pieces. Do we know what z is?
Yes.
Now, here's the thing. We know what z is because they're asking us about when x equals 4 and y equals 3. They're asking about the same moment in time. If they ask for a different moment, it would be harder. So, Jose, what's z? 5. dy dt, what do we got?
10.
Is going to be 10. 5 times 10 minus, I need y. 3. dz dt.
Negative 50. No.
Careful.
3.
dz dt.
Negative 6.
Negative 6.
Negative 6. Over z squared.
5 squared.
So it's going to be 5 squared. Hey, good news. That's all a number.
You can leave it.
You can leave it if you want to. That's fine. Or we can simplify. Now, here's the problem. What's cosine theta? Cosine of theta means adjacent over the hypotenuse. Anybody know the adjacent side at this moment in time?
Yes.
Yeah.
What's the adjacent side?
4.
The adjacent side for that angle
4.
is 4. At this moment in time, like the ship is frozen 4 kilometers away. What's the hypotenuse? 5.
5.
So you're going to have on this side 4 over 5 times d theta dt equals this stuff over here. You want to get d theta dt, you're just going to divide both sides by 4/5. So let's clean this up and do this the right way. We got 4/5 d theta dt. 5 times 10 was that 50 plus looks like 18. So 68 over 25. I want to divide both sides by 4/5. That's the same as multiplying by 5 over 4. So d theta dt, I can reduce, and I think we get 17 over 5. I am not worried about the reducing. You could leave it as 68 over 25 divided by 4/5 and get all the points. Here's where I want you to close out the conversation. What's the sentence that you would write to interpret this answer, and what are the units?
When x equals 4
Units and the
kilometers
sentence.
and y equals 3 kilometers. The theta.
You guys missed us.
The theta. The angle. The angle is increasing at a rate of 17 over 5 radians per hour. Would you just say angle? It's an angle.
So the strong explanation starts with, when is this true?
When x equals...
David, when's this true? Yep, a strong explanation starts with when this is true.
So when x equals 4 and y equals 3,
Okay, when x equals 4 kilometers and y equals 3 kilometers, what's true? What's changing?
The angle.
I want to be careful. It's not the rate of change of theta that's changing. It is theta that's changing. It's the angle. The angle between the two ships The angle between the two ships is, don't use the word changing if you can go stronger than that.
Increasing.
Increasing at a rate of, need the units. How do I measure my angle? How do I measure time? Not degrees. Never in calculus class. Never degrees. Radians.
Per hour.
Radians per hour.
Can we, instead of saying, angles, can we just look at a sine?
Theta.
You could say that theta is increasing at a rate of, that's fine. Okay, so tonight, here's what I want you guys to do tonight for homework. Multiple choice problems, there's 5 of them. Problems 1, 2, 3, 5, and 7. Free response, there's 2, it's questions 2 and 3. You guys have a little bit of time to work on that between now and when we leave. I want to focus on the friends in the front. Specifically, let's look at